Google just dropped the early preview of Gemini 2.5 Flash through the Gemini API in Google AI Studio and Vertex AI. This one's faster, smarter, surprisingly affordable, but this isn't hype 'cause numbers are backing it up. So here's the big question. What exactly did Google do here? And why might this be the AI model everyone's been waiting for? Welcome to AI Handbook. Today we will unpack Google's newest brainchild Gemini 2.5 Flash, and reveal the real-world benchmarks that might just change how you think about speed, cost, and performance in AI. Let's get started. Google just dropped Gemini 2.5 Flash, and here's something really interesting and a first for Google itself. They emphasize that Gemini 2.5 Flash is our first fully hybrid reasoning model, giving developers the ability to turn thinking on or off. This is a significant technical detail. Being fully hybrid suggests a new architecture or approach that combines different methods or components for reasoning, potentially making it more versatile or efficient than previous models. And this isn't just a small update. While they are delivering a major upgrade in reasoning capabilities, they are still prioritizing speed and cost. This tells us the core focus: better reasoning power compared to the previous 2.0 Flash, but crucially, it keeps the speed and affordability that Flash models are known for. This is a key point to build applications where quick, cost-effective responses are essential. They've also given developers a cool new control to set thinking budgets to find the right trade-off between quality, cost, and latency. This is a practical feature for developers. They can control how much thinking the model does, directly impacting how accurate the answer is, which is quality, how much it costs to run, and how quickly it responds, which is latency. This flexibility is huge for optimizing performance and budget for different use cases. They even mention what happens if you minimize that thinking. Even with thinking off, developers can maintain the fast speeds of 2.0 Flash and improve performance. This clarifies that you don't lose the core speed of the previous Flash model even when you reduce the reasoning effort. Here, Google tells about how reasoning models work. Basically, models think before providing the better response, and here, they emphasize that complex tasks require multiple steps of reasoning.
But why are they telling us all these things we have already been aware of?
Great point. Since they are providing a fully hybrid model that you can turn thinking capability on and off, they want you to be aware of what tasks need reasoning so you can act accordingly. Next, they say Gemini 2.5 Flash performs strongly on hard prompts in LM Arena, second only to 2.5 Pro, which is amazing. Being second only to the more powerful 2.5 Pro model indicates that Flash is punching above its weight in terms of reasoning, especially considering its focus on speed and cost.
So, it's faster and cheaper than Pro, but still really good at thinking? That's a great balance. By the way, what is the hard prompts benchmark?
Great question. So, let me jump on the webpage and explain real quick. What they say is, to evaluate the difficulty of a prompt, we define several hardness criteria, such as domain knowledge, complexity, and problem-solving. Prompts that meet multiple criteria are considered more challenging and are assigned a higher hardness score. These scores help us create a new leaderboard category, hard prompts. Basically, they define some certain criteria to evaluate how difficult the prompt is. For instance, for real-world application they ask, does the prompt relate to real-world applications? Or for problem-solving they ask, does the prompt directly involve the AI to demonstrate active problem-solving skills? As a question, other than that, you might find some example prompts in the blog post as well, like written 10 different sentences that end with the word Apple, which is under specificity, creativity, real-world criteria. I hope this small introduction helps you to understand it better. For more questions, feel free to write in the comment section below. I answer each comment. Okay. Let's dive into this benchmark table and see how Gemini 2.5 Flash stacks up, especially with its new thinking capability. I will just mention a few key points. Results are really amazing. First off, let's look at the pricing. The table shows the input and output prices per 1 million tokens. Input price 15 cents and output price 60 cents for no reasoning, $3.50 for reasoning. It is obvious that Gemini 2.5 Flash is priced very competitively, especially when thinking is off once you check Claude and Grok 3, which is ridiculously high. For humanity's last exam benchmark, Gemini 2.5 Flash thinking 12.1%. A score of 12.1% might seem low at first glance, but it's important to compare it to the previous version. Gemini 2.0 Flash non-thinking scored 5.1%. This is a significant improvement in reasoning capability when the thinking is enabled in 2.5 Flash. It shows that the new reasoning feature is indeed making a difference in complex tasks that require deeper understanding.
So, the thinking really does help with those tough reasoning questions?
Absolutely, and we see this pattern continue in other areas. Let's look at mathematics and science, which is around 78%. But let's be honest, these are impressive scores for a model focused on speed and cost. Only model that beats Gemini 2.5 Flash in this table is OpenAI o4 Mini. In code editing with Aider Polyglot, it is 51.1% for whole and 44.2% diff fenced. This benchmark measures the ability to edit code, so a score around 50% indicates it can be helpful for code editing, but might require some human oversight or refinement. Finally, let's look at visual reasoning with MMMU and image understanding, which I got the most excited about. Gemini 2.4 Flash scored 76.7%, visual reasoning MMMU. These scores are quite good, especially for visual reasoning. This indicates that Gemini 2.5 Flash has strong multimodal capabilities, meaning it can understand and reason about information presented in images. This is a valuable feature for many applications.
So, it's not just good with text, but also with images? That's really versatile.
Exactly. Overall, the table shows that Gemini 2.5 Flash, especially with its thinking capability enabled, offers a significant step up in reasoning and performance compared to its predecessor, while still maintaining a competitive price point. It's a strong contender for tasks that require a balance of speed, cost, and intelligent processing. As we talked earlier, users have the ability to turn thinking on or off. In addition, Google has enabled another setting, a thinking budget, that offers fine-grained control over the maximum number of tokens a model can generate while thinking. Here's the pro tip: even if the thinking budget is set too high, the model does not use the full budget if the prompt does not require it. Let's look at the first graph that shows Gemini 2.5 Flash on the science benchmark. The performance steadily improves as you give the model more thinking budget. Starting around 74% at 0K, it climbs to over 80% at 24K. This is a key point. For complex reasoning tasks, allocating more thinking resources directly boosts accuracy. Now, the second graph is Live Code Bench. This graph also shows an upward trend, and even for coding tasks, the thinking process is beneficial, although the gains might plateau after a certain point between 16K and 24K. So, check out these two graphs here. They visually demonstrate how the thinking budget directly impacts the performance of Gemini 2.5 Flash on different tasks. Below the graphs, it says, improvements in reasoning quality as thinking budget increases. This is the core message the graphs are conveying. More thinking time or resources allocated to the model leads to better results on tasks that require reasoning. It's a clear trade-off: you can choose speed, cost, or quality, reasoning power, or balance. Here's the pro tip: if you want to keep the lowest cost and latency while still improving performance over 2.0 Flash, set the thinking budget to 0. This is a crucial point for users prioritizing speed and cost. Setting the budget to 0 still gives you the performance uplift over the previous 2.0 Flash model, while keeping things as fast and cheap as possible. That's a wrap. If you found this video helpful, don't forget to hit that like button, subscribe for more AI news, and share this with anyone who might be interested. Thanks for watching, and I'll catch you in the next one.